Good afternoon, children.
Afternoon.
Good afternoon. So, how was your exam? Yes, tell me. How was your exam? Yes, tell me.
It was
Devi
good,
Krish.
Okay.
Yeah, okay. All of you? John?
Okay.
Okay. Shabari?
That's good, ma'am.
Good. I think most of you made some mistake in the MCQ questions 9 and 10. What's the equation to find out the number of nodes, children? Number of nodes. Number of nodes.
N-1.
Yeah, it's n minus 1, right? I will give you the question 3D, isn't it? N minus 1, that's the equation to find out the total number of nodes. And I will give you 3D. So how can we calculate the total number of nodes? That is equal to n minus 1. So here n value is 3, right? So 3 minus 1, that is equal to 2. And this another equations L, that is to find out the angular nodes. Then next one, n minus L minus 1. That's to find out radial nodes. To find out the total number of nodes, the equation is n minus 1. So here the correct answer is 2. Okay, children? Then one more thing. What about the maximum number of electrons that can accommodated in the p orbital? Maximum number of electrons that can accommodate in p orbital. Already in the case of p orbital, there are 3 types of orbitals. 3 orbitals are there, right? And each orbital will accommodate 2 electrons. So the maximum number of electrons accommodated by p orbital is 6, right? Many of you write 2. Why? I just checked only the MCQ questions, and in this section I have found out the common mistake. That's the question number 9 and 10. And while you're writing the electronic configuration of copper and chromium, you have to remember about the extra stability attained by half-filled and completely filled configuration. So in this 2 exceptions, after the completion of d orbital, the next electrons will be moved to s orbital. Okay. So in the next exam, you should correct it. Don't make mistakes in this type of questions. Clear? All of you switch on your videos. If you have no network issues, please switch on your videos. Then now we are going to discuss the structures, Lewis structures. I think we already do an example, right? Then now we are going to discuss another example. Do you remember the steps to write the Lewis structures, children? Devika, can you tell me?
Yes, ma'am. Ma'am, first step is to write the number of valence electrons. And then second step is to write the skeleton structure.
Yeah.
And then we join the single bonds. And then we do the double bonds.
Double bonds or lone pairs.
Lone pairs.
Okay. So we can do the example. Second one, NO2 minus. NO2 minus. Okay. NO2 minus. So we can start with the first step. The total number of valence electrons. First step, the total number of valence electrons. How many valence electrons are there in NO2 minus? John, can you tell me the number of valence electrons in nitrogen? Nitrogen.
5.
Yeah, it's 5. Then what about oxygen?
6.
So here 2 oxygen atoms. So 5 plus 6 plus 6. This is completed. The total number of valence electrons. Yes?
Yes, ma'am.
Yes?
Yes, ma'am.
Then what about this negative charge? Yeah, so one more electron is there. If there is negative charge, you have to add one more electron. If there is positive charge, you can subtract one electron. Okay, so here 5 electrons from nitrogen, 6 electrons from each oxygen atom. Then 1 electron that's due to the negative charge. So the total number of electrons is 6 plus 6, 12, 12 plus 5, 17, and plus 1, 18, right? This is the first step. Total number of valence electrons. Then the second step. Draw skeletal structure. Draw the skeletal structure. While drawing the skeletal structure, you have to place the least electronegative atom at the center. Okay, least electronegative atom at the center. So among this nitrogen and oxygen, nitrogen is the least electronegative atom. So we will place nitrogen at the center, then 2 oxygen atoms on the both sides. This is the second step. Then the third step, draw single bonds. Draw single bonds. So to draw single bonds, each atom will share one pair of electron, right? Yes. So we can draw the bonds between these two. This is the third step. Third step. Then we are moving to fourth step. Draw double bonds or lone pair. Lone pair means the electrons that not involved in any chemical bonding. That is considered as lone pair of electrons. Draw double bonds or lone pair. So here you know that total 18 electrons are present, right? 18 electrons are there. Then already 4 electrons are subtracted from here because the 2 electron pairs are here to form for the formation of single bond, right? Out of 18 electrons, 4 electrons are involved in the single bond. So remaining 16 electrons, isn't it? 16 electrons. Because the 4 electrons,
Okay.
yeah. Aditya, any doubt?
Yeah.
No. Okay. So in the case of this single bonds, 2 electron pairs are already shared. So we can deduct 4 electrons from 18. Then it will be 16, right? Then the remaining 16. Yeah, okay. Okay. Thank you. It's 40. Okay. So the remaining 14 electrons are represented either as lone pair of electrons or double bonds. Two options are there. Either you can represent as lone pair of electrons or double bonds. Okay. So we can start with lone pair of electrons. 14 electrons remaining. So we will start with the most electronegative atom. Okay. In the case of oxygen, already 2 electrons there. Then the remaining 1, 2, 3, 4, 5, 6, right? Then we can draw the 6 electrons in next oxygen atom also. When you count the number of lone pair of electrons on oxygen atom, now it's completed, right? 1, 2, 3, 4, 5, 6, 7, 8. Last one from the bond, shared pair of electrons. Then now how many electrons are remaining? how many electrons are remaining? Yes, from 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 electrons are distributed to each oxygen atom. Then only 2, right? These 2 electrons will be represented on nitrogen atom. Okay. Then you can count the total number of valence electrons present in nitrogen atom. Tell me, what about the number of valence electrons in nitrogen atom? Is it 8? Tell me. Anyone? Malavika, can you tell me? Valence electron in nitrogen. It's 6, right? According to octet rule, when they involved in chemical bonding, they should obtain 8 electrons. So this representation is wrong. So we will take these 2 electrons from any of the oxygen atom and it will be shared between the nitrogen and oxygen. So we can rewrite this structure. One oxygen, nitrogen, oxygen. Here, the total number of electrons, lone pair of electrons, that is 6 itself in this oxygen atom. Okay. And here we will shift this 2 electrons towards both nitrogen and oxygen. That means a double bond will be formed between nitrogen and oxygen. Then we can draw the remaining lone pair of electrons. Now you can count the total number of valence electrons present on each atoms. In the case of first oxygen, 1, 2, 3, 4, 5, 6. Then along with this bond, 8 electrons. Then nitrogen, 3 bonds are there. So 6 electrons. Then the remaining 2, it will be 8. 8 electron, right? Here also 8 electron. And the last oxygen, already 2 bonds, so 4 electrons. And the 4 lone pair of electrons, 8 electron. So this is the correct method of drawing this Lewis structure. First, you have to find out the valence electrons. In the second step, draw the skeletal structure. So while drawing skeletal structure, the least electronegative atom at the center. Then draw the single bonds between the different atoms. Then the fourth step, draw double bonds or lone pairs. So you will start with lone pair and then you will able to find out which is the missing bond there. Then you can draw the double bond. So this is the Lewis structure of NO2 minus, nitrate ion. This is clear, children? Any doubt in any step?
Ma'am,
Yeah.
ma'am, can I explain fourth step?
Fourth step, after the drawing the single bond, we can either draw double bond or lone pair. Okay, so we will start with lone pair. Already 4 electrons are shared between the bonds, so remaining 14 electrons, right? So we can draw this 14 electrons. Please mute your mic. Yeah, it's okay. So first we can starting with oxygen atom. Okay. First we can start with oxygen atom. So the remaining 6 electrons are represented on each oxygen atom. Then only remaining 2 electrons that will be given to nitrogen atom. Then when we count the total number of valence electrons of each atom, in the case of nitrogen, it is not considered as octet. 8 electrons are not there in nitrogen. So in order to make the outermost shell of nitrogen as octet, we will share the electron pair from one of the oxygen atom to nitrogen also. So it will be converted as a double bond between nitrogen and oxygen. This is clear now?
Yes, ma'am.
Have you completed this example? Yes, right? Then let's try with another one. Okay. Then next one, we can draw the structure of CO, carbon monoxide. All of you just try with carbon monoxide. Carbon monoxide. After that, we can discuss. Switch on your videos. Yeah, Gaia made it. It's okay. Those who have network issues, it's okay. Otherwise, switch on your videos. Aditya, Anjana, Erin, Lakshmi, Jyoti, Shreya, Rose, Sanjana, Hanaga, Alan Joshi, Jacob, Rahul, Ardra, Meryl, Renil, Elaine, Nimita. All of you switch on your videos. Yes, have you completed? Valentina, can you tell me the total number of valence electrons?
10.
Yeah?
10.
Yeah, it's 10. Then what about the skeletal structure? Carbon, oxygen. Then the third step, we will draw a single bond, right? Okay. Then tell me, Alantina, how can we distribute the remaining electrons? Out of 10, 2 electrons are shared between carbon and oxygen. Then only 8 electrons. Then tell me.
2 in the carbon side.
2 for the?
Carbon side.
Yeah. We will start with oxygen, right? So here 6 electrons. Then the remaining 2 with carbon, isn't it? Yes. Then while you checking the total number of valence electrons present on oxygen and carbon, in the case of oxygen, it's already completely filled, right? 8 electrons are there. 1, 2, 3, 4, 5, 6. Then the shared pair of electrons, 8, right? But in the case of carbon, 1, 2, 3, 4. Only 4 electrons are there, right? Only 4 electrons. So how can we make it balanced? Or how can we make the octet of carbon? Valentina?
Adding 2 more electrons pair. Electron pair.
Yeah, so we can give these 2 electron pairs shared between carbon and oxygen, right? Then it will become C triple bond O. Then 2 electrons here, 2 electrons here. This is the Lewis structure of carbon monoxide. Carbon monoxide. Clear? We completed, children? Yes or no? Yes. Then the next example, we can draw the structure of CO3 2 minus. Draw the structure of CO3 2 minus. Carbonate ion. Pooja, can you tell me the total number of valence electrons? Pooja,
Yes, ma'am.
for carbon, how many electrons? Tell me.
4 electrons.
4. Then what about oxygen atoms?
6 into 3.
Yeah, 6 plus 6 plus 6. Then
Then plus 2.
yeah, plus 2, because here it is 2 minus, right? So 2 more electrons are added to this valence electrons. Then total 24, right? Yeah, okay. 24. And how can we draw the skeletal structure? Yes. Carbon at the center, then 3 oxygen atoms surrounded by this carbon, right? Then in the third step, we will draw the single bonds between these 3 oxygen atoms with carbon. So already 6 electrons are shared. So 24 minus 6, that is 18 electrons remaining. So how can we distribute these electrons as lone pairs, Pooja? How many electrons on each oxygen atom? Yes, anyone? Shabari, can you tell me how many electrons on each oxygen atom?
6.
Yeah, 6 electrons. Because 18 electrons are remaining, we will distribute this 6 electrons to each oxygen atom. Then you look at the valency of carbon. Valency or the octet of carbon. Only 6 electrons are there, right? So in order to make it octet, we will share the 2 electron pairs with carbon atom. Then it will become C. 1 minute. C, then 2 oxygen atoms with 6 electrons. Here double bond is between this oxygen and carbon, because 2 more electron pairs are shared between carbon and oxygen. Then we can draw the remaining 4 electrons. That means 2 pair of electrons. Now you again check the total number of valence electrons of carbon. Now it's 1, 2, 3, 4, 5, 6, 7, 8. In the case of each oxygen atom also 8 electrons. So this is the final Lewis structure of carbonate ion. Clear? So clear, children? Have you completed this one? All of you?
Yes, ma'am.
Then we are moving to the next example, the last one, that is ozone. O3. O3. Ozone, that is O3. So the total number of valence electrons. Anashwara, can you tell me?
Ma'am,
Yeah. Total number of valence electron in ozone.
6 into 3.
Yeah, 6 into
18.
3, that is 18. Okay. Then what about the skeletal structure? Here the 3 atoms are same. So we can draw it like this. 3 oxygen atoms. Okay, then the next step, draw a single bond between these oxygen atoms. Then how can we distribute the electrons? Already 4 electrons are shared. 14. Yes. So tell me, Anashwara, how can we distribute the remaining electrons? 14 electrons. So the terminal oxygen atom with 6 electrons, right? 1, 2, then 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So already 12 electrons are distributed, then only remaining 2. These 2 electrons will be at this oxygen. Then we are counting the total number of valence electrons present on each oxygen atom. In the case of the terminal oxygen atoms, it is 8. But in the case of the oxygen atom at the center, 1, 2, 3, 4, 5, 6. Only 6 electrons. So we will share the 1 pair of electrons with the oxygen atom in the center. Then it will become O. One, 2, 3, 4, 5, 6. And here 1, 2, 3, 4. So this is the final Lewis structure of ozone.
Ma'am,
Yes.
I have a doubt, ma'am.
Yes, Sarah?
Ma'am, why 18 is not?
18, because 6 electrons in each oxygen atom, 6 into 3, 18, right?
Yeah,
Clear?
no, ma'am.
Why? The valence electron present in each oxygen atom. That is 6, right? While you're
Yes,
writing the electronic configuration, 1s2, then 2s2, 2p4. This is considered as the valence shell. So the total number of electrons is 4 plus 2, that is 6. Here in the case of ozone, 3 oxygen atoms. So 3 into 6, that is equal to 18. Clear? Sarah?
okay, okay. Yes, ma'am.
Yeah. So have you completed this one? Do you have any doubt in drawing the Lewis structures? This is clear, right? So we are moving to the next topic, that is about formal charge. Formal charge. The formal charge of an atom in a polyatomic molecule or ion, it may be defined as the difference between the number of valence electrons of that atom in an isolated or free state and the number of electrons assigned to that atom in the Lewis structure. So this is the equation to find out the formal charge of each atom present in a molecule. The formal charge of an atom in a polyatomic molecule or ion. What's the meaning of polyatomic molecule or ion? That means the molecule with different atoms. Switch on your videos, children. Yes. The formal charge of an atom in a polyatomic molecule or ion may be defined as the difference between the number of valence electrons of that atom in an isolated or free state and the number of electrons assigned to that atom in the Lewis structure. We know that the number of atoms in the Lewis structure, it will be different from their valence electrons, right? So here we will find out the difference between the total number of valence electrons of that atom in isolated or free state and the number of electrons assigned in that atom in the Lewis structure. So this is the equation to find out the formal charge. Formal charge, that is equal to total number of valence electrons in the free atom minus total number of non-bonding lone pairs of electrons minus half into total number of bonding electrons. So this equation is very important. Formal charge, that is equal to total number of valence electrons in the free atom minus total number of non-bonding electrons, that is lone pair, minus half into total number of bonding electrons. So this is the equation to find out the formal charge of each atom present in a molecule or ion. Have you completed the slide, children?
No.
Okay. Renil, can you please read the slide? Renil.
The screen is not visible for me.
Okay. Ardra, can you please read? Ardra.
Ma'am, the
Yeah.
screen is not visible for me.
So I will share it again. Just wait. What about now? Renil?
Yes, ma'am.
Okay. Then read.
Formal charge. The formal charge of an atom in a polyatomic molecule or an ion may be defined as the difference between the number of valence electrons of that atom in an isolated or free state and the number of electrons assigned to that atom in the Lewis structure. Lewis
Yeah, in the Lewis structure. Okay. Then read the equation. Yes, formal charge is equal to Naurin, can you read? Renil, it's okay. Only the equation.
Yes, ma'am.
Yeah.
Formal charge is equal to the number of valence electrons in the free atom minus the number of non-bonding electrons minus half non-bonding shared electrons.
Yes. So we can do one example for find out this formal charge. Okay. We can start with ozone itself. Do you remember the Lewis structure of ozone? So you can redraw the Lewis structure of ozone. Wait, children. This is the Lewis structure of ozone. So we can number each oxygen atom. This is the first oxygen atom. Then here it is the second one. Here it is third one. Then we are going to find out the formal charge of each oxygen atom. So we are starting with the oxygen atom 1. First oxygen atom. That means the oxygen atom at the center. So here this is the equation, right? Total number of valence electrons in the free atom minus total number of non-bonding electrons minus half into total number of bonding electrons. So here can you tell me what about the total number of valence electrons in the free atom of oxygen? Total number of valence electrons in the free atom of oxygen. That means the total valence electron of oxygen.
6.
Yeah, it's 6, right? 6 minus, here the total number of valence electrons in the free atom minus total number of non-bonding electrons. So how many electron pairs are there? How many lone pair of electrons in first oxygen atom?
2.
Yeah, it's 2. Only 2 electrons, right? 2 dots are represented. So 2 minus, again it's half into total number of bonding electrons. That means the shared electrons. Half into, how many electrons are shared? 3 bonds are surrounded with the central oxygen atom. That means 6 electrons. Yes. So 6. So 6 minus 2 minus 3. That is 1, right? Positive 1. So this is the formal charge of oxygen atom at the center. That's the first oxygen atom. Okay. This is the formal charge of the first oxygen atom or the oxygen atom at the center. Then we are moving to the oxygen atom numbered as 2. So can you tell me? Here also the same equation can be applied, right? So what about the total number of valence electrons in oxygen atom? Yeah, 6 itself. Then here total number of non-bonding electrons. That means lone pair of electrons. 1, 2, 3, 4, 5, 6. 6 dots are there, right? So 6. Again minus half into total number of bonding electrons. Only one bond is between the second oxygen atom. So that means 2 electrons are shared. So what about the formal charge of second oxygen atom?
0.
Minus 6, that is 0. Then again it's minus. Yes, tell me children.
-1.
Yeah, it's minus 1. Minus 1. Plus 2 by 2, that is 1. Here 1 minus star, so minus 1. Then the next one, third oxygen atom. Oxygen atom numbered as 3. Here also the total number of valence electron is 6. Then how many lone pairs are there in the third oxygen atom? It's 4. 1, 2, 3, 4. 4 minus half into how many bonded pairs are there?
4.
Because 2 bonds are there between third and first oxygen atom. So each bond contains 2 electrons. So it's 4. So 6 minus 4, it is 2. Again 2. 2 minus 2, that is equal to 0. So this is the formal charge of third oxygen atom. So we can redraw the Lewis structure with the formal charges. Here the first oxygen atom with plus 1 charge. And this one is the third oxygen atom, right? So the lone pair of electrons with 0. So you need to represent no numerical value. Then the next one, 1, 2, 3, 4, 5, 6. And the second oxygen atom with -1 charge. So this is the formal charge distribution of each atom in a molecule. So you have to learn the equation to find out the formal charge. Then you can find out the formal charge of each atom in a molecule or ion. Then you can assign the charges. This is the method of drawing the Lewis dot structure with formal charge. This is clear, children?
Yes.
All of you?
Yes, ma'am.
Then we can discuss the remaining things in the next class. Okay. So all of you just practice the Lewis dot structures, then the formal charge, etc. in the next class. Okay. Let me take your attendance. Just wait.
Thank you.
Thank you, children. Bye.